Dear students, welcoming you all again for another video session on problem solving in transient response with the DC input. So in the previous video we have solved some of the problems already. So in continuation to that video we will solve different problems in this video. So consider this RL circuit which is having two different voltage sources with a switch. So in this circuit the switch is closed at position 1 for long time, and at t equal to 0 the switch is closed to position 2, and you're asked to find the current through the circuit when the switch is at position 2, and also 3 milliseconds after closing the switch to position 2, what is the current flowing through the circuit. This is what you are asked to find. So let us assume that the switch is closed at position 1 for a long time. So this source will not deliver any current, hence you can leave it. So this is the position 1 where this 5 volt source will circulate current through this circuit. Now since the switch is closed at 1 for a long time, the current flowing through this circuit would have reached steady state. We have already discussed the current response in an RL series circuit. So initially the current will be increasing slowly, and at one point or one time the current will become constant. That is what we call it as steady state. So what is the steady state current here? Okay. Now what is the voltage across the inductor equation? It is L into di by dt. So at steady state, after this current becomes constant, you can see this current is constant. When you differentiate a constant, you will get 0. So this entire term will become 0. So voltage across the inductor becomes 0. That means what? And the inductor will act as a short circuit. So at steady state, the voltage across the inductor is 0. It means that it will act as a short circuit like this. So the effect of inductor is no more in this circuit. So then now the current flowing through the circuit at steady state will be simply V by R. That is 5 by 2, it is 2.5 amps. So in the previous problems we had only one source and the initial condition I of 0 is equal to 0. Now because of the presence of an additional voltage source, there is a initial condition exists. So this I equal to 2.5 amps will be the initial condition when the switch is closed to position 2. Now you can see here the switch position is changed to 2. Now the 5 volt source is disconnected from the supply and the 20 volt source is connected. Now we're going to find the current I of t in this circuit. So as usual we will be writing Kirchhoff's voltage equation. So we will get 20 minus 2 into I of t minus 0.2 di of t by dt equal to 0, and just rearrange the terms. It is as simple as the previous problems what you have solved, and take Laplace transform. So this I of 0 is the initial condition. The meaning for initial condition is the current flowing through the inductor at the instant the switch is closed from position 1 to 2. So already we found that when the switch is at position 1, the current flowing through the inductor is 2.5, and now when the switch is closed to position 2 also, the current initial condition current flowing through the inductor will be 2.5, because the inductor does not allow sudden change of current. So at the moment of closing the switch to position 2, the initial current flowing through the inductor will be 2.5. Hence this I of 0 is 2.5. Earlier problem we would have substituted 0 here. Now it is 2.5, and the rest of the simplifications will be same. So just multiply this inside, take the 0.5 to the right hand side, and we are interested in finding IFS here, so take IFS outside. So bring this denominator to s plus a format. So take the coefficient of s outside, and now bring this 0.2 to the numerator. It will become 20 by 0.2 plus 0.5 by 0.2 s. So that is 100 plus 2.5 s. Now we need to find I of t. So it is required to take partial fraction. So by partial fraction you can write this expression equal to a by s plus b by s plus 10, and after finding the coefficients a and b, that is for finding a, put s is equal to 0 here, so you will get a equal to 10, and for finding b, put s is equal to minus 10, b is found to be minus 7.5. Substitute a and b values in this expression. Now it is easy to take inverse Laplace. So 10 by s will become 10, and 7.5 divided by s plus, this is of the form 1 by s plus a, so e power minus at. So this is the current flowing through the circuit when the switch is changed from position 1 to 2. Now in the problem it is asked to find the current 3 milliseconds after the switch is closed to position 2. Now in this expression, wherever you find t, put t is equal to 3 milliseconds, that is 0.003 seconds. So I of 3 millisecond is equal to 10 minus 7.5 into e power minus 10 into 0.003. It comes out to be 2.72 amps. So this is the final answer. Problem number 2. So assume an RC series circuit connected to two different voltage sources. As in the previous problem, the switch was at position 1 for a long time, and when the switch is closed to position 2, find the transient current, and also 5 milliseconds after the switch is closed to position 2, what is the current. That is what we are going to find. Now assume that the switch is at position 1 for a long time. So what will happen now? This 5 volt source will be circulating a current through the circuit, and hence the capacitor will be charged. Since the switch is at position 1 for a long time, the capacitor would have charged to the maximum voltage of 5 volt. So voltage across the capacitor would have reached steady state, which is equal to 5 volts. You can see here, this is the polarity of the voltage across the capacitor, that is 5 volts. Now we are trying to change the position from 1 to 2. At t equal to 0, the switch is closed to position 2. Now what will happen? This 5 volt source is disconnected, and this 20 volt source will be circulating current through this circuit. It is required to find the current I of t when the 20 volt source is connected. So by using KVL, we will write Kirchhoff's voltage equation, that is 20 minus 2 into I of t minus 1 by c integral I dt, where this value of c is 1 farad. So you can write 1 here. Sometimes they may give in microfarads also. So in such case, it will be 1 into 10 power minus 6. Now just rearrange the terms, bring this 20 to the right hand side, and take Laplace transform. So we know that Laplace transform of this will be 2 into I of s, and Laplace transform of this will be I of s by cs plus v of 0 by S, and this is 20 by S. Now here V of 0, what is this V of 0? It is the initial voltage across the capacitor when the switch is closed from position 1 to 2, and we already found that when the switch was at position 1, the voltage across the capacitor is 5 volt, and when it is changed to position 2 also it will remain 5, because the capacitor does not allow sudden change of voltage. So at the moment of closing the switch to position 2 also, the voltage across the capacitor, initial voltage is 5 volt. So that is what we will substitute here. Right. Now again, further simplifications, we are interested in finding IFS, so bring IFS into one side and do the simplifications. So take LCM here, and the S will be cancelled. So IFS into 2S plus 1 will be equal to 20 minus 5S. Yes. Now bring this 2S plus 1 to the right hand side. Make this into S plus A format. So take 2 outside and bring this 2 to the numerator. It will become 10 minus 2.5 S by S plus 0.5. Now we can directly take inverse Laplace by writing like this: 10 divided by this minus 2.5 S by this. So this is of the form 10 by S plus A, so e power minus 80, where A is 0.5. And here this is of the form S by S plus A. The inverse Laplace of S by S plus A will be d by dt of e power minus 80. That is, you have to differentiate this again. So when you differentiate, e power minus 0.5 t will be e power minus 0.5 t into minus 0.5. Hope you all agree with this. And when you multiply this with 2.5, you will get plus 1.25, and e power minus 0.5 t is common. So this is the current flowing through the circuit when the switch is closed from position 1 to 2. Now we are asked to find the current 5 millisecond after the switch is closed. So that is, put t equal to 5 milliseconds, that is 0.005. It comes out to be 11.22 amps. I hope all of you have understood this problem. If you have any doubt, please go through the videos again, and you can also call me for further clarifications. Thank you all.